Hello and welcome to this presentation related to advanced transposition of formulae. This presentation has been produced with the intention of developing transposition skills for technician engineers who are progressing directly to undergraduate study in engineering at university. The formulae we're going to consider within this presentation are quite complicated and beyond that required for general technician engineering study. Thus the reason this presentation has been termed Advanced Transposition of Formulae. Here's a brief presentation overview. The presentation is constructed by showing examples and then having an associated exercise based on the example. For all examples and exercises, the full steps used within the transposition process are outlined. So considering example 1, we're given this formula in terms of T to rearrange or transpose for variable V, and I said the full work steps in the transposition are shown. Then there is an exercise associated with example 1 where we commence with the same formula. This is actually written on one line, not two lines here, but it's the same formula as in example 1C. But this time we're going to transpose for variable E. And again, the steps undertaken in this transposition are shown in the exercise. Then we have example 2. Given the formula shown here, we have to transpose now for variable A, and note A occurs twice within this formula. And then exercise 2, same formula as for example 2, but now written on one line. This time we have to transpose for variable B, and again B occurs twice within the formula. Just note within the presentation I've used different styles of brackets within some calculations to aid clarity. So for example here, my outside bracket is shown in this style, but the inside brackets have a more conventional style. You do not need to use these different styles of brackets, but I'm just trying to use them here to aid clarity of the transposition process. And here are the approximate start times related to these various examples and exercises, but please note these times are rounded to the nearest minute. Presentation overview continued. Here we have example 3. Subject is Z. We've got to transpose the formula for variable C, shown here. And this is exercise C. And again, the same equation for Z, but now in one line format. And this time we've got to transpose for Greek symbol lowercase omega, and that actually occurs twice within the formula. Example 4, an equation in terms of Q. We're asked to transpose the equation for a variable h, height, and exercise 4, a slightly different equation but still in terms of Q, capital Q this time. And now we've got to transpose for area A0, shown here in the formula. And again, here are the approximate start times related to these various examples and exercises, but these times are rounded to the nearest minute. Presentation overview continued. So we have example 5C, heat transfer equation here in terms of quantity Q. We have to transpose for variable xc, shown here. And then exercise 5, very similar formula, slightly different notation. Again, the subject is Q, but this time we have to transpose for constant K2, shown here. In exercise 5, the formula is shown in one line format again. Finally, the presentation concludes with some tutorial questions for you to undertake at your own pace. There are no work solutions for the questions. And here are the approximate start times related to example 5, exercise 5, and the commencement of the questions. But again, please note these times are rounded to the nearest minute. So as introduction, this set of notes is designed with the intention of helping students prepare for direct entry into electrical or mechanical undergraduate engineering study, and that's with regards to their mathematical development. The topic we're covering within this presentation relates to advanced transposition, and as mentioned previously, it does build on the introductory and the further transposition lectures. So these notes contain a series of worked examples followed by related exercises for you to attempt. Note that the solutions are generally shown using one-line formatting, which although can complicate the presentation, should help students develop a greater understanding of the use of precedent rules or BODMAS within the transposition process. As I said, this presentation is really aimed at students who already have reasonable proficiency in transposing formulae and equations. And for further reference, there are two other previous presentations that relate to the current topic. The first one entitled Trigonometric Proofs, where we use basic trig and Pythagoras theorem to prove various formulae given. And there is a part 2 of that presentation where we use the sine and cosine rule, again to prove various formulae given. And of course, within both of those presentations, you need a strong underpinning knowledge of transposition. Let's consider the first example, example 1. With each of the examples and the exercises that follow, there will be a context given because most of the formulae we're considering in this presentation have been extracted from previous presentations, be that specifically mathematical presentations or engineering science type presentations, but the context of the examples and the exercises is essentially relevant to the essence of the presentation, which is totally focused on transposing these more advanced formulae. So I'll let you read the question and the context, but essentially the formula we're given here, T, is equal to 2 multiplied by V divided by G, and that's multiplied by the bracket of 1 divided by 1 minus E. So currently T is the subject of the formula, but we're asked to make the subject V. So we have to transpose it for a symbol V here. If you want to attempt this, please feel free to start the presentation and do so, but I'm going to show you the full work solution on the following slide. So example 1C, here's the solution. This slide shows the format of how these solutions will be presented in each example or exercise. In the shaded box shown here, I'm stating the steps I'm undertaking in the transposition process. On the right hand side shows the associated actual rearrangement of the formula. So we're asked in this particular example to transpose for V. So given the equation stated as T as a subject, we have to transpose for V. So first step in the process, I multiply throughout by G, shown here. Next I multiply by the bracketed term, 1 minus E, shown here. And finally I divide by 2, shown here, to produce my final solution for V as the subject of the formula. Just note this last line essentially shows the same formula for V, but instead of dividing by 2, I'm now multiplying by a half. So it's just a different format for the final solution. Here's exercise 1C for you to attempt. Exactly the same context. The only difference here is that the formula for T is now written on one line. So I have 2 multiplied by V multiplied by G to the negative 1. It's reciprocal of G. And that's multiplied by the bracket of 1 minus E. But that's raised to the power of negative 1. Again, indicating it's reciprocal. So for exercise 1, we're asked to make E the subject of the equation. The final rearranged form for E is shown in the bracket here. I would encourage you to stop the presentation and try and solve exercise 1C, but a full solution is shown on the following slide. Here's exercise 1C, solution. So this time we have to transpose for E, given our equation for T, which is written on one line here. So we're transposing for variable E here. So my first step, I multiply by G divided by 2V. That's shown here. I'm just using the bracket for the 2V to ensure my BODMAS is correct in this particular case. Then I'm actually inverting both sides, finding reciprocal of both sides if you like. I'm turning them upside down. So now I have 2V divided by TG, and again I'm using the bracket to ensure BODMAS is correct here. And I've inverted the right hand side, so it becomes 1 minus E. Next I add E to both sides of the equation to make it positive, shown here. And finally I subtract 2v multiplied by in the bracket tg to the negative 1 from both sides of the equation to give my final solution for E. So that's my approach to this problem. With all the solutions, you may find a different, maybe a more preferable, more concise solution to the problem, and that's absolutely fine. I'm just showing you my suggested solution here, that's all. The essence of this presentation is for you to develop your transposition skills. This is exercise 1C. I've called it an alternative solution. I just started the solution from the two-line format for T. So it's 2v divided by g multiplied by in the bracket 1 divided by 1 minus e. But the final result will be exactly the same, transposing for E. That's just for your reference, really. Here's example 2C. We're asked to transpose the formula given for A. Formula that says P divided by Q on the left-hand side equals to the square root of, in the bracket, A plus 2B divided by A minus 2B. So we're transposing for the A term here. It occurs twice in the formula. I'll show you the full work solution on the following slide. So example 2 solution. So we're asked to transpose the formula for A. Notice I have used the one-line format here purely for conciseness of the slide in this particular case. So to commence the transposition process, I square both sides of the equation. I let's multiply throughout by the bracket A minus 2B, shown here. I expand the left-hand side, shown here. I add 2B multiplied by in the bracket P divided by Q all squared to both sides of the equation. I subtract A from both sides of the equation. I now factorise both sides of the equation, left-hand side a factor on A, right-hand side a factor on 2B, and finally I divide by the square bracket shown here. That shows me the rearrangement for variable A, and again I've just shown a slightly different format on the last line using the reciprocal index. So here's exercise 2C for you to attempt. This time we transpose a variable B. Again, note B occurs twice within the formula. And I've shown you the answer on the right hand side here for variable B. I'd encourage you to stop the presentation and attempt this exercise, but the full work solution is shown on the following slide. Exercise 2C, here's the solution. I have to transpose the formula for B. B occurs in two locations within the formula. Notice I've just written the formula on one line here for conciseness. So, commence the transposition process by squaring both sides, shown here. And on the right hand side, of course, the half becomes a 1. We're using my index notation. Notice that a half signifies the square root operation in index form. Next, we multiply both sides by q squared multiplied by a minus 2b in the bracket. So on the left hand side we have the a minus 2b term. On the right hand side we have the q squared term. To try and aid understanding, here is two-line formatting for reference. So multiplying the numerator throughout by this term occurs here on the left hand side, here on the right hand side. And we can see that this q squared term in the numerator cancels with this q squared term in the denominator. On the right hand side, the a minus 2b in the bracket in the numerator cancels with the a minus 2b in the denominator, resulting in this line. Then we expand the brackets on both sides, so expanding on p squared on the left hand side, expanding on q squared on the right hand side. Now we collect the a terms on the left hand side and the b terms on the right hand side. So I've subtracted the aq squared term from both sides and I've added the 2bp squared term to both sides. Now factorise the left hand side on a and the right hand side on 2b, shown here and here. and finally divide throughout by 2 multiplied by in the bracket q squared plus p squared, shown here. I've just used different style brackets again for clarity purposes. So now we've rearranged the formula for b, and I've just shown b in a slightly different format here. Instead of dividing by 2 on the previous line, I'm multiplying by a half now. I could have also written this line by multiplying the bracket of p squared plus q squared all to -1 if I wanted to. Here's example 3. This has an electrical context, but again, we're primarily interested in the transposition process. The formula for impedance, Z, in terms of the square root of, in brackets, R squared plus, in another bracket, omega L minus 1 divided by omega C, and that bracket's all squared. Notice again, different style brackets have been used, but that's purely to aid your ease of understanding of the formula as presented. We're asked to transpose the formula to make C the subject, and the solution is given here. If you want to attempt example 3 before I show you the solution, please feel free to stop the presentation, but the full work solution is shown on the following slide. So example 3, here's the solution. We're asked to transpose the formula given for capital C, and here's the formula given, and again I'm showing it on one line for conciseness. So notice the 1 divided by omega C here is written as omega C to the power of -1 in a bracket, of course. We have to transpose for C. So my suggested process is to square both sides of the equation. So of course that removes the square root on the right hand side. And subtract R squared from both sides. Square root both sides. Removes the squared term here. Add the omega C in the bracket to the power of -1 to both sides of the equation. Subtract the square root of in the bracket z squared minus r squared from both sides. Then invert both sides. So we lose the -1 on the left hand side, but we have a -1 occur on the right hand side. Again, notice the right hand side is all in one bracket here. Then finally we divide throughout by omega. I've shown that as omega does -1 here. So there's our solution to find C as the subject, and again I've just shown an alternative form on the final line, accounting for the -1 reciprocal notation. Here's exercise 3C, given the same formula for Z. This time we have to rearrange to make omega the subject. Omega occurs twice within this formula. There is a hint in the question. We've got to make use of the quadratic formula to generate the final solution. That's how we'll end up with this plus or minus operation in the middle of the formula. I'd encourage you to stop the presentation and attempt exercise 3C, but a full work solution is shown on the following slides. Exercise 3C, here's the solution. We're asked to transpose the formula for impedance Z to make lowercase omega the subject. So again, for convenience, I'm commencing from the one line format here. And we're rearranging to find omega. So my first step is to square both sides. Then subtract r squared from both sides. Then square root both sides. Removes this squared term here. Multiply throughout by omega. So omega occurs here. Omega squared occurs here. But this omega cancel because of course that's 1 upon omega because of the -1 index. So the omega cancels with this term here. Then I've subtracted omega multiplied by the square root of in the bracket z squared minus r squared from both sides. So that's shown here. And that leaves me with a quadratic in omega. Think of that as a generic ax squared plus bx plus c format. So note this equation here is actually in the quadratic form of ax squared plus bx plus c, but this is a quadratic in omega, so it's the form a omega squared plus b omega plus c. So note in this case, the A is L, the B is negative the square root of, in brackets, z squared minus r squared, and constant lowercase c is actually equal to the negative uppercase c to the negative 1. So that's our quadratic in omega. Now we can solve directly for omega. Exercise 3c, solution continued. So just repeated this line here for convenience from the previous slide. It's our quadratic in omega. I'm now going to apply the quadratic formula, generic form here. X is equal to the negative b plus or minus the square root of b squared minus 4ac, and it's all divided by 2a. Note for reference, I could have added a bracket around the 2a term for completeness to ensure my correct BODMAS, but it's not required as long as I realise I have to divide by 2a. So in this case, our x is equal to omega, our a is equal to L, our b is equal to negative square root of, in the bracket, z squared minus r squared, and lowercase c is equal to uppercase c to the negative 1. I'm now going to insert these values into the formula, so to insert the value of the b coefficient here and here. Notice I just ignored the negative from this term because it's been squared. Here's the a term, here's the c term, and we're all divided by 2 times the a. I'll let you work through the next line on your own. We can then conclude that omega is equal to a half multiplied by L to the negative 1, and in this big bracket here we have this expression. And we can clearly see that's the same as what's given in the original problem. Just note in the original problem they state the formula using the index of a half, I using the actual square root symbol. Example 4, we've got to transpose this fluid mechanics equation, currently in terms of lowercase q, for h. H is shown here in the numerator. Again, if you want to attempt this example before seeing the solution on the following slide, please feel free to do so, but the full solution is shown on the following slide. So example 4c, here's the full solution. We're transposing for h, given the formula for q here. H is shown in the numerator here. So first step, I've divided both sides by area A1, shown here. Next, I've squared both sides, shown here, left hand side, and remove the square root sign from the right hand side. Now I multiply both sides by the square bracketed term shown here. And finally, I divide both sides by 2g, shown here. We've now rearranged the equation for lowercase h, and then again I've just shown h in a slightly different format than the last line. Exercise 4c, we're given a formula for flow rate capital Q. This time we have to rearrange for the area of the orifice labelled as A0, and that occurs in 2 locations within the formula. Here's the final rearranged format for A0. Again, I would encourage you to stop the presentation and attempt exercise 4, but the full work solution is shown on the following slides. Exercise 4c, here's the commencement of the solution. We're given our formula in terms of flow rate Q. We have to rearrange for A0, and A0 occurs in 2 locations within the formula. The first step in the process, I will divide throughout by CdA0, so it's removed from the right hand side and occurs in the denominator on the left hand side. Next, square both sides, square left hand side, and of course on the right hand side the square root sign is removed. And next we multiply by this bracketed term here, which is the denominator of the right hand side, and it occurs in the numerator on the left hand side. Exercise 4c, solution continued. Just repeated this line for convenience from the previous slide. Next we square the terms in the first bracket on the left hand side, shown here. We divide the second bracket by a0 squared, shown here. a0 squared cancels for the second term in the bracket. We multiply throughout by cd squared divided by q squared, cancels on the left hand side, occurs over here on the right hand side. We add 1 divided by ap squared to both sides of the equation, so this term is over here. We invert both sides of the equation, so turn the left hand side upside down, we have a0 squared. Turn the right hand side upside down here. Then we square root both sides, so square root the left hand side, we have now a0, square root the right hand side. And all that's happened here is the right hand side has been raised to a fractional index instead of the square root sign. We've now rearranged the equation for a0, and I've just shown a different format on the final line for a0. I've just inverted the right hand side, so I've made the index a negative here. So that's the solution for exercise 4c. Here's example 5, extracted from our heat transfer presentation. We're given the formula for heat transfer Q, and in this particular question we have to transpose for thickness xc. The full work solution is shown on the following slide. Example 5, here's the solution. So transposing for xc, given the equation for Q, here is xc. So firstly I've multiplied by the bracket and divided by Q. So here's the bracket, left hand side. Here's the Q now on the right hand side. Note we no longer need the bracket on the left hand side. Now I'm going to subtract xp divided by kp and xb divided by kb from both sides of the equation, shown here. Finally I'm going to multiply throughout by kc, shown here. Notice I've reintroduced the bracket here. So here's a solution for xc. Exercise 5c. We're given a very similar equation for Q, slightly different notation in the denominator here. I've got to rearrange to find K2, shown here. The answer for K2 is shown below for your reference. I'd encourage you to stop the presentation and attempt exercise 5, but the full work solution is shown on the following slides. Exercise 5c, here's the full work solution. We're transposing for K2, given our formula for Q. Here is K2. So first step, multiply throughout by the bracket and divide by Q. So dividing by Q here, multiply by the bracket. Note that the bracket on the left hand side is no longer required, so it's been removed here. Next we will subtract x1 divided by k1 and x3 divided by k3 from both sides of the equation, shown here. Exercise 5, solution continued. Just repeated this line for convenience from the previous slide. Next we're going to multiply throughout by q, k1 and k3. So on the left hand side the q, the k1 and the k3 appears. On the right hand side we have K1, K3 here, Q cancels for this term, Q and K3 appears for the second term, the K1 is cancelled, and Q and K1 appears for the third term, the K3 is cancelled. Now we factorise the right hand side on Q, shown here. Then we multiply throughout by K2 and divide by the right hand side terms. So this allows us to have K2 as a subject, and then we're dividing by the right hand side here. And that's our solution in this particular case. I will now leave you with a series of tutorial questions for you to undertake at your own pace. They have different contexts. The first one is electrical context, question 1 here. We're given an equation in terms of resistance R12, shown here. We've got to rearrange to make R30 the subject, but it occurs twice within the formula shown here. Here's the final transposed form. Question 2c, got to rearrange to find B, given the formula shown here. Notice that B occurs in the numerator and the denominator. Answer for B shown here in the bracket. And question 3c, the equation for lowercase q here, we have to rearrange for A1, which occurs here. The answer A1. Question 4, we're given the equation for volumetric flow rate, capital Q, and here we've got to rearrange the formula to solve for AP. AP is shown here, squared term, and the solution for AP is shown in the bracket here. Question 5c, again we're given a formula for volumetric flow rate Q. This time we have to rearrange to find delta H, shown here in the formula, and the rearranged form for delta H is shown here in the bracket. Question 6, given the equation for lowercase q, we have to rearrange for A2, shown here, and the solution for A2 shown in the square bracket here. Question 7c, actually an equation given to me by a student that he was using within his industrial workplace. It's a quite complicated formula shown here. We have to rearrange this formula for XP. XP occurs twice within the formula given. And here's the final answer we need to prove for XP. And question 8. We're given two simultaneous equations that are shown below. Here's the first one. Here's the second one. And we've got to show that the current I1 is equal to the expression shown here. So that's a simultaneous equation problem. I hope this presentation has been of use to you in some way in advancing your transposition skills. I wish you every success with your progression to engineering undergraduate study. Thank you for viewing.